Good morning, folks. This is Aaron DeBruin here once again to Vinyl Freak 89 here to give you an update on the situation for March 8th, 2008. Alright, so the first thing that we're looking at this morning, this is a visible satellite picture over the Midwest, and the reason why I'm bringing this out to you is to highlight the most key player in this entire system is this bad boy sitting right in here, this cold front. That cold front, where the farthest east that it goes, look about 250 miles to the west, or I'm sorry, 150 to 175 miles to the west of that, and that's where you're going to see your axis of heaviest snow. At this point, it looks like the front is going to settle in probably, I'm thinking right in this area in here, stall out, which means the axis of heaviest snow is back right in here and then up the coast. So something like that is my current thinking to the axis of heaviest snow. Of course, that can change. Actually, you know what? I'm bad time first drawer at these things. More like this. Definitely more. Wouldn't put West Virginia in that. So yeah, that's where I'm thinking the axis of heaviest snow is going to be right now. But of course, that can certainly change as we get closer to the system. So that's the first thing we're going to take a look at, and again, watch that front, that's the key player. Notice that it is starting to try to disconnect back here from our second system coming out, our main system, which is what I'm going to talk about now in the upper levels, what I'm going to call the breaking up of the PVA tail. So let's go ahead and get right to it. We'll start by taking a look at the current upper air pattern. You can see, or actually this is 4 hours ago, and one thing that I noted, and I did highlight this before on the thread, and I'm going to highlight it again. This is what I mean by a PVA tail. This sort of a tail that extends from disturbance 1 in here to disturbance 2 back here. This connection, this is what we mean when we talk, well, not necessarily, but this is what we mean in this instance when we talk about phasing. This connection in here. And what that means is this disturbance is going to get yanked out in front. I don't care how strong the jet is on the backside. If that tail is sitting in there like that, this disturbance will get yanked out in front rather than being able to dig down. And that's what we're seeing that's sort of causing the demise of this system. Now, I said in the thread we needed to have a 6-hour window where this tail could disintegrate. Watch what starts to happen. Going on to, this was valid 10 o'clock this morning, or I'm sorry, 9 o'clock, going on to 10, you can see it's still in there, 11, it's still in there, but now as we get on into the last hour, you can see it's starting to maybe think about breaking up. If we do see a definitive separation, you can see there's a slight one, but if you see a definitive separation where this piece comes back and this piece rushes out in front and you see a nice separation that's at least this wide in here, then the tail will have definitely been broken. Remember, what you're seeing on the GFS, I'm sorry, in this case, any of the NSET maps, they only start at 16 meters per second of vorticity, so you can't so there is still something that's going on below there, but once you get below about 8 meters per second, 8 to 10 meters per second, it becomes negligible because that just becomes background interference in the atmosphere. So keep in mind, even though it looks like the tail's broken, it is still connected, just at a slightly lower vorticity. Okay, so we'll have to watch that over the next couple of hours, see if it continues to break, and this piece retrogrades back to the west. Again, if it breaks and this piece continues east, well, the tail's still there, you just can't see it. So we need to see retrogression of this piece and progression of this piece. That's what the true tail breaking would do. So again, we'll back up, we'll watch the progression. Again, watch. There's 4 hours ago, 3 hours, 2, 1. There's ever so slight progression of this, which is not what we want to see. It is, you can see it's sort of, it's, again, staying in there. It does jump back for a sec, and then it jumps ahead again. So, whoops, not updating the map. Sorry about that again. You can see it jumps back, then it jumps ahead, but it's not really moving all that much. So the tail is trying to break because of that strong jet on the backside, but it hasn't done it yet. The other thing to note is watch what happens because we have that tail. Here's the main piece of energy. It's actually splitting into two pieces. part 1 is out front here, part 2 is sitting behind. This is the problem. This piece in here jumps out too fast, drags the trough like this, and it goes negative tilt too early. And so what happens, rather than getting a big storm that comes out of the Gulf of Mexico and goes up the East Coast, you get the same big storm, but it comes out of the Gulf of Mexico and goes up the spine of the Appalachians. That's basically what happens. Again, watch what happens in the 4-hour progression. Starting to move northeast. But look, this piece is digging in. And this piece is jumping out front. That's not what we want to see. We want to see them to dig together. Again, watch this. 1, 2, 3, 4. So you can see this piece moves from about here into here, and this piece moves from about here to here. So they're jumping out. One piece is jumping out ahead, and that's why you get the trough that tries to cut off like this, which I'm going to show you on the GFS run, and why we end up with a system that cuts up to the west of the Appalachians. Now, this is the one possible saving grace behind this system.